The dark energy is quite interesting component in the cosmology, and the theorem is always in the point of view of the standard model. The dark energy is a light-time cosmic accelerations with the double dot of the scale factors of the universe expansion is positive. It means that the universe is expanded with rapid accelerations. From the second Brodmann equations, the two dots of the double dots of the A is positive, is equivalent with the negative project. The rho plus 3 times the project is negative. So if we define the equation of the state omega as a relative between the projects and the density, then this equation of the state should satisfy the less than the minus one of those conditions. And the simplest realizations of the dark energy is the cosmological constant, capital lambda, in the right-hand side of the Einstein field equations. Like that. And this gives the negative contributions in the energy densities in the right-hand side of the Brodmann equation, and eventually it gives the equation of the state equal to the minus 1. But this cosmological constant is just the constant energy density. But one can consider dynamical dark energy because such a constant energy density is not consistent with the recent data like as a DAGI, and such a dynamical dark energy can be motivated through with the specific particle physics model like as a quintessence field. And also such a dynamical energy is motivated to resolve the several problems of the cosmological constant. The first of all, the recalled cosmological constant scale for the Brodmann equations and the Beckmann scale from the quantum fluctuation is not the same. The energy density from the cosmological constant is roughly 10 to the minus 47 CeV volt power from the critical energy density. But if we calculate the Beckmann energy scale from the Planck mass scale, then the discrepancy between the observed dark energy density from the critical density and the Beckmann energy scales are 10 to the minus 120. It's quite large discrepancy between the two values. This is called naturalness problem. So this means that the Beckmann is insufficient to give the cosmological constant. And the second problem is the coincidence in the accelerant approach in the current universe, because the energy density of the dark energy does not vary over the cosmic time. It's just given by the constant value, but the energy density of the matter components reduces to the 8 to the minus 3, and the quite recent universe that around to the 2 or 3 what other value, I don't know the exact value, but this matter components and the dark energy components are comparable, and this makes the universe the transit from the matter dominant to the dark energy dominant. But this requires that the two components, the dark energy and the matter components, energy density should be the comparables in the current approach, and this is quite typical fine-tuning. This is called the coincidence problem. And also the other motivations for the dynamical dark energy is observational test. Rather than the constant equation of the state equal to the minus 1, we can fit into the epochs the double jets over the scale factors. The simple parameterization is a linear one. This can be written in terms of the ladder shift jet rather than the scale factors A. And such a Bowing equation of the state changes energy densities of dark energies in these differential equations and the solutions. Then along the changes of the equation of the state, also the energy densities of the dark energy that changes, unlike the constant cosmological constant. So such a dynamical dark energy model can provide the effective equation of the states and might resolve the naturalness and the coincidence problem. And also the dynamical dark energy can provide the microphysical framework, like some specific particle physics and the build model, and the effective the deviations they can be analyzed. So far we talk about there are two big approaches: the constant dark energy and dynamical dark energy. But now we'll talk about the wide dark energy that necessary. There's many relevant observations from the astronomical and the cosmological one by using the geometric proofs. The lifetime acceleration can be argued by the several geometric proofs like the supernovas 1A, baryon acoustic oscillations, and the cosmic microwave background (CMB). This all gives the relation between the distance and the redshift by the expansions of the Hubble parameters over the redshift. The Hubble parameters by the Bradman equations, the first Bradman equations, the H0 contains the critical energy density, and we can divide both each cosmological contributions from the radiations, matters, curvatures, and dark energy, and they are changes with the different proportionality. For the radiation, it decomposed as a to the minus decreased as a to the minus 4, and the scale factors can be changed to the redshift, and the matter components that decreased along the a to the minus 3, and the curvature term a to the minus 2, but the dark energy is constant. And along the changes of the Hubble parameters with the difference component contributions, this gives the co-moving distance by integrations of the Hubble parameters properly. And the observable listed in the astronomy is a luminosity distance by measuring the distance modulus of the type 1 supernova. Because type 1 supernova is the standard candle with the same luminosity for all the same type, so that this can be the standard candle to analyze the distance from the Earth, so that we can estimate the specific distance from the Earth to the type 1 supernova, and this can be used to analyze the geometric proofs and how the Hubble parameters changes. Also, the other observables related with this Hubble parameters and distance. For the baryon acoustic oscillation, the positions of the BA of peaks are related with the 2-point correlation functions. So there are some specific peaks in here. If we plot the correlation functions over the R, where the R is the distance between the 2 points, and also we can plus over the power spectrums over the frequencies, then this gives us some oscillations behavior. This gives a baryon acoustic oscillation, because this, if we put a transformation the peak, this gives us some specific oscillations behaviors. And the separations angles of the baryon acoustic oscillations are determined by the sound horizons, because such a baryon acoustic oscillations are coming from the when the baryons and radiation components that are mixed with each other, and this gives the oscillations behavior. So similar to the supernovas 1A, BAO can give the standard rulers to measure the distance scale, and also that we can analyze the Hubble parameters and how much the dark energy components contributes in these equations. And finally, the CMB also can provide the geometric proofs how much dark energy that contributes to the energy density components in the universe. Because also the in the power spectrum there is also the power spectrums like that by plotting sort of the angular momentums by expansions with the spherical harmonics, and this angular momentum L also depends on the horizontal distance. So the this comes from the Hubble's parameter. So the CMB by when we beating the CMB power spectrums, the dark energy contributions, the light years of the dark energy density of the critical density is quite important parameters. So if we beating this CMB by an acoustic oscillation supernovas 1E about the parameter space of the dark matters and dark energy light years, it behaves like something like that. Then there might be some best point, and the dark matter has light years of 0.3 and dark energy 0.7. And also there are another observables from the integralized Sachs-Lupus box, so-called ISW. When the CMB photons pass through some specific astronomical objects, then they suffer some gravitational potentials. But and these photons get some temperature isotropies of the CMB depending on each directions. But when these gravitational potentials varies over the time, then the temperature and isotropies of these CMB photons are different. For the meta-dominance approaches of the universe, the gravitational potentials, capital pi and capital psi contributions are negligible. But when the dark energy becomes the dominance over the cosmic history, then the gravitational potential contributions are non-zero, and this makes the anisotropy of the CMB photon temperatures that changes, and also so the dark energy contributions can be tested. So in the current observations, the around 0.68 to the 0.7 light years is the dark energy. By combining the CMB type 1 supernova and baryon oscillation. And also recently the dark energy spectroscopic instruments, briefly DAGI, reports the cosmological data, and this analyzed the linear parameterizations of the equation of the state, and this gives the omega G, the constant parameters is not equal to the -1, and the linear coefficients WA is not equal to 0. So that there it might be the deviations from the just the constant lambda, the constant cosmological constant. I mean the lambda CDM values is such a model is quite different. And also there are two well-known observational discrepancy which might be resolved by the dynamical dark energy. The first one is Hubble tensions. If we measure the Hubble parameters in the distance ladder, this yield h is zeros to the 73 kilometers per second per megaparsec. But if we obtain the Hubble parameters by the early universe proofs, like the CMB, then the Hubble parameter h0 is given by the 67 kilometers per second per megaparsec. There is the 5 sigma difference, and such discrepancy between the Hubble parameters for the early universe and the right-time universe observations can be resolved by the additional physics, like as the dark radiations contributions or dynamical dark energy. And also there are other tensions called S8 tensions. S8 defines by the like that, and there are two discrepancy between the CMBs and the weak-ranging observation. Such two tensions can be resolved by the modifications of dark energy. So far we talk about the observational point of view of dark energy, and the remaining time I will talk about the dynamical dark energy through the various model. Rather than the static cosmological constant, one can allow the dark energy evolve through the time. The simple realizations of the quintessence scenarios by the introducing the scalar field, like as the in Platon. The scalar field in the expanding universe has the following actions, and if we evaluate the annodances and the projects, then we can obtain the equation of the state in terms of the field gradients and the potentials. And the equation of the states are the same to the in Platon actions and the white dark matter, because this is the same as scalar field dynamics in the expanding universe, and we want to obtain the light expansions. This means that the kinetic energy term is the subdominant, and the potential energy is the main contributions and density to gives -1 equation of the state. So the important one is how can we determine the shapes of the potentials, and this gives the different behaviors of the scalar field dynamics. The simple example is exponential potentials, which is called exponential quintessence. This admits the scaling or tracker-like attractors behavior. So the scalar density follows the dominant background component. So before the dark energy becomes a dominant, the universe has the MD approach. So the scalar field density follows the Matheson density during the RDs and MD. So this can resolve or alleviate the constant problem by the reducing the sensitivity of the initial conditions. But the such a tracker behaviors also makes the difficulty of tying the right-time accelerations with the pure exponentials. So because the scalar fields has the same behavior to the matter-like behavior, so to make accelerations in the right time is very hard. So one should modify the model rather than the pure exponentials, like as a multiple exponentials, or the other factors modifies the potentials. So there is another class of quintessence potentials proposed, so-called inverse power law, or the lateral People's potentials. Also, this show the tracker solutions. So even though the initial condition has a wide range, the field converts some specific attractor solutions. So this also follows the background expansions, and eventually the coincidence problems can be resolved. Problems the model building perspective, such exponentials on the inverse power potential, can arise from the non-perturbative dynamics in Santoni fact, because it contains exponential terms. Also the AD associated potentials can provide such inverse power law potentials naturally. And the remaining time I'll talk about the other dynamical dark energy model. The other one is the phantom dark energy with the long signs of the kinetic term. This gives the equation of the site less than the -1 with the super acceleration. But there's such a phantom dark energy with long signs of the kinetic term now make the ghost and problems of instability. So the propagators is unhealthy. This gives the some ghost build. The other alternative is the chaos answer with the non-canonical kinetic term rather than the canonical kinetic term. So we can introduce this sort of functions of the p in the Lagrangians, where the p is the function of the scalar field pi, and the kinetic term x, and the function of the p is the not typical one. And this gives the sound space as in terms of sort of the first and the second derivatives of this function p, and the density perturbations might different. Also, we can couple the dark energy to the other structures. Then the connected or coupled structures and dark energy transpose another each other. The well-known there is a mass balance neutrinos, or by coupled neutrinos and dark energy, and this gives the neutrino mass balance over the time, and also the effective potential changes and the energy transpose between the dark energy and neutrino. So such a dark energy is quite interesting areas in the particle physics and the cosmology, because still unknown and mysteries in the model point of view, and current observations and the recent data reports the dark energy might not be just constant. There might be just dynamic dark energies, and also point of view of the as a resolution of the naturalness and the coincidence problem. So such a dynamical dark energy can include the particle physics model approaches too.